Alright, in this video we're going to be looking at 9.2, the Pythagorean Theorem, and how we use it. Alright, before we get into the Pythagorean Theorem, we're going to go over some review of how we simplify radicals. So we take the number inside our radical, and we find the largest perfect square that goes into it. So let's recall our perfect squares. Well, a perfect square is a number multiplied by itself. So for instance, 1 times 1 would give us 1, 2 times 2 would give us 4, 3 times 3 would give us 9, 4 times 4 would give us 16, 5 times 5, 25, 6 times 6, 36, 7 times 7, 49, 64, 81, and so on. So we want to keep those in mind when we're working with reducing radicals. So let's do some examples. We have the square root of 24. We need to think of our factors from 24, and we want to find the largest perfect square that is a factor of 24. Our factors of 24 would be 1 times 24, 2 times 12, 3 times 8, 4 times 6, and that's it. So we want to look at all these numbers and see if any of them are perfect squares. So remembering what our perfect squares are, we can see that 4 is a factor of 24. So we'll break our radical into our factors. We have 4 times 6. So 4 times 6 gives us 24. So we split it up into two separate numbers. And then we can go one step further and split this into two separate radicals. So the square root of 4 times the square root of 6. But the square root of 4, we should know what that is. That's just 2. So we have 2 times the square root of 6. So that would be how we simplify radicals. Go ahead and see if you can do the next one on your own. So if we split 48 into our factors, we have 1 times 48, 2 times 24, 3 times, and don't be afraid if you have to use your calculator because I do too. Sometimes I don't remember all my factors. 48 divided by 3 is 16, 4 and 12, and 6 times 8. Alright, looking at this, looking for perfect squares, 16 is a perfect square. That's 4 times 4. So we can break up our radical into 16 times 3. Then we can go a step further and break it into two separate radicals. So square root 16 times square root of 3. And the square root of 16 is 4. So we get 4 square root 3. Alright, so now that we have a review of radicals, let's go into the Pythagorean Theorem. So the Pythagorean Theorem only applies to right triangles, so when we have a right angle in our triangle. So if we have a triangle, ABC, then we can use the equation a squared plus b squared equals c squared, where a is our side across from our A angle, b is our side across from our B angle, and c is across from our C angle. And it's important to note that the side alone on the right side of our equation is always going to be the hypotenuse. So let's use this definition to label some triangles. So in this case, we have the triangle STU. So notice our side across from our angle U is U, our side across from T is T, and our side across from S is S. So again, the side across from our hypotenuse, so T, that's always going to be the side that's alone. So we'll have equals T squared. And then our other two sides are going to be added together on the left. So U squared plus S squared. So again, our hypotenuse is alone squared, and then we add our legs together squared. Alright, so we're going to find the unknown side length using Pythagorean Theorem, and we're going to simplify any radicals that we find. So our side across from the right angle, our hypotenuse, that'll be alone. So this will be equals x squared. And then our legs will be squared and added together. So 7 squared plus 9 squared. Simplifying, 7 squared is 49. 9 squared is 81. It's equal to x squared. This is going to be 130 equals x squared. The way to cancel out a squared so we get x on its own is to take the square root. So we take the square root of both sides. And so our square root and our squared cancel, and we just get x. And then we have the square root of 130. So we have to think if there's any perfect squares that go into 130. So what I'm going to do is, with my calculator, I'm going to remember all my perfect squares. So 1, 4, 9, 6, 16, 25, 36, so on. And I'm going to divide 130 by each of those numbers to see if any of those are a factor. So 130 divided by 4 is 32.5. So it's not a whole number, so it's not a factor. 130 divided by 9, that's 14.44 repeating, not a factor. 130 divided by 16, 8.125, so that one doesn't work. 130 divided by 36 is 0.833. So it doesn't look like 130 has a factor that's a perfect square. So we can't simplify this any, so we'll just leave it like this. See if you can do part B on your own. So in part B, the side across from our right angle, our hypotenuse, is 17. So that'll be on its own on the right, squared. And then our legs are x and 11. So we'll square those and add them together. X squared plus 11 squared. And so now we just have to solve for x. So we have x squared plus 11 squared, which is just 121, is equal to 17 squared, which I don't know off the top of my head, 289. So now we have to get x on its own, so we'll do inverse operations. The opposite of adding 121 is subtracting 121. So we have x squared is 289 minus 121 is going to be 168. Then to cancel out this squared, we have to take the square root, both sides. So our squared cancels with the square root. We need to check if any of our perfect squares go into 168. So I'll take 168 divided by 4. Perfect, that's 42. So we have x is equal to the square root of, so 168, its factors are 42 times 4, which we can rewrite as the square root of 42 times the square root of 4. But the square root of 4 is just 2, so we have x equals 2 root 42. And that's it. Alright, so now we're going to look at area. So to find the area of the triangle, we can use the equation a equals 1/2 times b times h, where b is our base and h is our height. Now, when we have a right triangle, like in our example, our height is just going to be one of our legs, and our base is going to be the other leg. But when we don't have a right triangle, we have to draw the height down from the vertex, perpendicular to our base. So it's a little bit more simple when we have a right triangle. So let's do this example. We have to find the area of this triangle. Well, to be able to find the area of our triangle, we need a base and we need a height. In this case, 6 inches is our height, but we need to figure out what our base is because we don't have the second leg. So we can use Pythagorean Theorem. 10 is our hypotenuse, so that's going to go alone on the right side of our equation. And then we don't know what our base is, so we'll call it x. So we have 6 squared plus x squared. Then we just have to solve for x. So 6 squared is 36 plus x squared equals 10 squared is 100. So we have plus 36, so we have to do inverse operations. Subtract 36. So we have x squared equals 100 minus 36 is 64. And then to cancel out our squared, we have to take the square root. And so our square root and our squared cancel. And we just have x. And luckily, 64 is a perfect square, so we can just take the square root right away. And that is 8. So our height is 6. Our base is 8. So plugging into our area formula, we have 1/2 times 6 times 8. Well, 6 times 8, that's going to be 48. And then when we multiply by 1/2, that's the same thing as just dividing by 2. So we have area is 48 divided by 2. Well, 48 divided by 2 is just going to be 24. And since we're talking about area, our units are inches squared. Alright guys, that's it for summer school. I'm really proud of you for chugging along, getting it done. I know it's probably not what you wanted to be doing with your time, but proud of you for getting it done. Hopefully you enjoyed these videos. I sure did like making them, but I'm kind of biased because I like math. But hopefully be seeing you in the future. It's been real.